Okay guys, so now we are going to learn about stream APIs in Java. So let's create a new project in IntelliJ. If you haven't done this already, haven't installed IntelliJ, please go back right to the start of this series where I will show you how to do that. So we'll call this project streams. We'll add some sample code and create that right here. We'll get a new window with our project. Cool. So previously, we spoke about lists and objects, and this is really a good follower on, really. Let's create some space here. Okay, so imagine like a stream as sort of like a stream of water or sort of a conveyor belt, right, in a factory. You know, it lets you process a lot of different items in the conveyor belt. So, example, you might have like one behind the other, like this. And your conveyor belt's going this way, and the elements are like bits of an array, right? So imagine this is an array, and it's on this conveyor belt, and slowly but surely, you know, the conveyor belt is bringing them all down and down and down and down until the final one is at the bottom, and we have nothing left in our conveyor belt. And we sort of, that conveyor belt will be used to like process each one individually. So let's say, you know, we have a conveyor belt of 10 items and we want to put them into packages one by one. And then by the end, there'll be nothing left on the conveyor belt. Hopefully that analogy kind of makes some sort of sense to you, but it might make more sense when we go ahead and implement this. Now you're probably thinking, what on earth is this useful for? Well, you see, when we have an array, let's say we have 1, 2, 3, 4, 5, 6, 7. If we want to search this array, if we want to, you know, manipulate values in this array, and also if we want to do things like sorting, which are possible to do, you know, with the standard for loop and all that stuff. But there's an easier way of doing that in the newer versions of Java. So here's what we'll do. We'll create a list of, let's say, strings. And this is going to be a list, not an array. This is quite important. So streams only work on lists. Right, so the ones that look, you know, like this. Right, with the object type, and then we can perform all kinds of operations on those. And essentially, they can do many things. They can sort, they can search, they can filter. So if we wanted to filter out some names in this array, let's say we have Ben, Jacob, Sophie, and Sophia. If we wanted to filter out only the names beginning with S and put them into one bucket, then we can do that using the Stream API in a very, very easy way without us having to do that logic ourselves. And we can basically process each one of these one after the other, which is technically what a for loop does, but the Streams API is kind of like a simplification for things that we can already do ourselves. So let's actually start writing some code, and you might be able to see what I'm on about. So let's create a list of names, right? So it's going to be a list of string, like we said before, and we'll call this names. And we're going to say, you know, equals new array list, just like we did with the standard list before. If you haven't seen the episode on lists, please go back to that in this series and watch that. I think it's 2 videos behind this one, or maybe 3. You'll have to figure that out. Essentially, let's add some items, right? So we can initialize these as items here, but I'll just add them all manually just for readability. So we'll go names.add, let's say Ben or Buen, names.add Jacob, and we'll go names.add Sophie, and then we'll go names.add Sophia. Okay, cool. So we now got our array that is full of elements. I keep calling it an array. I should really call it a list, but they represent the same sort of abstraction here. So a list that has all of these names in. Right, so now here's where streams come in. So let's say we want to, filter down our data set here, which is Ben, Jacob, Sophie, Sophia, into only names that start with a certain character. So let's use the stream API. So here's how we do this. We go names, dot, and we have all these options, and one of them will be called stream. So we have this stream here. So let's type stream, and then press enter. And essentially, here's how we create a stream. Now, let's just press enter so we can read this, not inside there, but outside like this. If we press dot again, we get all these different functions. So we find any, find first, filter, distinct, and all this stuff. We can go into those in a bit more detail later on in this video and later on in this series. And we can see sorted here allows us to sort. We can convert it to a list or to, a normal array if we want that to be in a normal array. So, but the one we're going to use to get the S names, the names that start with S, we do this. So we'll go dot filter. And then inside here, this is the syntax that we use. We use this sort of lambda syntax. So now imagine that we're iterating over this. And inside this filter, we have access to just one of these elements. So we can make the equivalent of what I would be, right? The counter I would be in a stream, except for it's not going to be a counter. It's actually going to be the value itself. So let's say current name, space, hyphen, and then greater than symbol to make an arrow. It will look like that, and space again. And what we can do is current name dot starts with, and again, this is just a function on the string itself. So if we have a look at string, you would eventually be able to scroll down this, and I did that by going Command or Control and then clicking. You would eventually find that function exists within the class string. So this allows us to perform this sort of operation on a string where we can see if it starts with a certain element, right? So, S. Now obviously, this is going to be case sensitive. So what we should do really is convert it to a lowercase. So then it doesn't matter if, this is lowercase or uppercase or anything like that. So let me just comment this. We'll say filter down names to ones beginning with S. And obviously this is all completely doable with the normal way of doing things where you write your for loop and all that stuff. But the Streams API really makes it easier for us. So now we're able to filter down to the names that start with, S after we've converted them to lowercase. And this conversion isn't going to mutate the value in here. Okay, this is just going to convert it to a lowercase for now, and then we can, see if it starts with S. So now I've pressed enter. Then all we need to do is go dot, and then we type collect. And this allows us to be at the bottom of this sort of conveyor belt, if you will, and sort of scoop up all of the new values that we have that have passed through this filter. Now, the only ones that would have passed through this filter are these two here, so Sophia and Sophia, because they both start with S. Now, we go collectors dot to list, like that. And then obviously, because this is all a line, it's just one line in Java, we need a semicolon after that. Now, obviously, if we run this, it won't do anything. But let's try and output the list now. So let's output names. And let's press run. And we were expecting to only see Sophie and Sophia, but we've actually seen all of them, even though they don't start with S. Now, why is this? Well, because we've done all of this, but we haven't actually saved the result anywhere. So that's what we need to do. We need to now put this inside a variable. So we just create a normal list. We go, in front of it, we'll go list of type string, filtered string equals, and then this whole thing here. So then now we actually have the new list where we've actually filtered it down. So now, instead of printing out names, let's print the filtered string. And actually, it should have an S on the end because it's multiple strings. Now let's run and see what we get. Nice, we get the two that we wanted. And also, we can change this S to anything we want. We can change it to J, and then press run. And hopefully we'll see, Jacob, sick. And if we type, B, we'll get Ben. And we can type more characters as well. So for example, if we wanted only the SOs, which is still both of these because they're similar names, we should get those two here. But then if we go SOF, which is where the first difference in these two strings is, hopefully we'll only get one element. Cool. So this is how the filter works in a stream. So hopefully that analogy makes sense. And essentially, when we're inside this stream, before we've collected anything, this is a single element. And this right here is what we call a lambda expression. So we can basically filter based off of the Boolean result of what this is. Right? Now, we can do multiple things in a stream. We can filter again if we want, right? We could say filter name, and by the way, we can name this what we call a predicate, whatever we want, but we could say current name or current name, which is what I'm using with this arrow, and we can do whatever we want here. So let's filter again, and let's say current name, and this is, the current element that we're on, right? So for example, if we're on the second, loop of this, we'd be at Jacob, or if we're on the first, we'd be at Ben. The current name dot length, for example, should be greater than, 5, right? So now if we do this again, and if we just make this S, what do you think will happen? Let's run it to find out. Okay, so now we've got the answer of just Sophie. Now, the reason why is because we filtered by S. So now, obviously, only these two are going to be able to even get to this next step, because the other two have been filtered out. So, we go here, and then, it doesn't meet the criteria, so we just chuck it away straight away. It doesn't even make it to here. Now, obviously, we filtered down to those two. Then it goes to the next line, and we make it to this filter here. So we sort of change these two filters together to create, sort of like a validation, if you will, like a certain criteria it must meet to make it into this filtered strings array. And this is a new array as well. What we can even do is reassign the names, array to that, and then we can use that later on. Because obviously the old array doesn't really matter anymore, so we can just sort of reassign it and discard what was there previously, and that would really be more memory efficient. So if we run that, we'll get the exact same thing as we did before. And obviously Sophie is the only, string that begins with an S that has a length greater than 5. So if we have 1, 2, 3, 4, 5, 6, whereas this name down here has 5. So that 5 is not less than 5, it's equal to 5. So it will never make it into the final list that we collect down here. Also, what we can do is we can actually just iterate over that list normally. So if we just get rid of these two filters here, let's scrap the idea of filtering, and let's do something else that we can do in streams. So now let's try and make sure that they're all unique, right? So we do that by using the stream.distinct filter, where we can basically filter down all of, get rid of all of the duplicates and then collect them as a list. Now, obviously, if we run this, we will get all of the elements that we had previously because there were no duplicates. But let's just introduce a duplicate, right? So now we have 2 Sophies in that list instead of 1. Let's try running that. As you can see, that duplicate gets completely, discarded from the array because of this distinct function here. Now, again, as I say, all of this is achievable with a normal for loop and a normal iteration, and writing your own code for this. But there's no need to if we can use the Streams API, which is built into Java. Now, another thing we can do is we can actually, write out the value for each one. So for example, before this distinct, we can go like, for each, for example. And a for each is, exactly what it is. We can say for each name, we can go like system.out.println name, right? But when we do this, we're not able to collect it into a list. That is the only drawback to using this for each. So if we wanted a for loop just to print out all of the names, then we could do that by just using this here. Now, the reason why I've got rid of a few other things is because we can't really assign, a variable to this because this returns nothing. It's just a for loop. So if we run this, we should see everything get printed in order. So Ben, Jacob, Sophie, Sophia. The reason why we have that duplicate is because we obviously took out what we had before. Now, as I say, this is just a few of the things you can do with the Streams API. These are the basics of it. So if you ever find yourself filtering or sorting or trying to, get rid of distinct, having distinct values in your array or your list, then this is what you would want to use. So yeah, hopefully that covers the basics of the Streams API. Hopefully you guys understand that. If you have any issues or questions, please comment below. And have a good one. See you in the next one.